You have your piece of colored paper, yes? Okay. First thing I need you to do is I need you to fold it. Fold the holes, but only a little bit. Does that make sense? Yes or no?
Yes.
Okay. Now, I need you to see how the holes are matching up right now? I need you to slide it over a little bit. Actually, how are we going to do this? Okay, let's do it this way. Let's flip it over. So see how the fold is down right now? But it's like this. I need to scoot it to the side. I need the top and bottom lined up, but I need to scoot it to the side a little bit. Okay. And then I'm going to make three real quick cuts. They're just little right now. See where I just cut? Right above the bold. And then you need to do another one right here, right above the bold. And then one more down here, right above the bold. Everybody understand what I just did? Yeah? Guys, please keep in mind this. I buy this paper, so please don't be wasting it. Okay? What's wrong?
You cut one of these holes?
No. I cut right above the bold. The bold writing. The bold writing. Okay. Now I'm going to flip it back over. The reason I gave myself a guideline is because when I'm cutting now, I can't see anything under the paper, and I need to cut as straight as I can, all the way to the fold. I'm not going to cut past the fold, I'm just going to cut to the fold. But I'm going to use the guidelines that I just gave myself for my initial cuts. Okay. I'm going to go ahead and match my corners up, the holes on the paper, and put 4 staples in here. I put one at the top, one above the middle hole, one below the middle hole, and then one at the very bottom. Okay? Does that make sense? So 4 staples. 1, 2, 1, 2. But that's after I turned it back over and cut. Here you go. Here you go. Yep, when your table group gets done with the stapler, please pass it on. You need to see where they are again? Here, 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 here. Okay, you're cutting way too many, you're doing way too many cuts. I just did 3 cuts. 1, 2, 3. But unfold it. Unfold it. Unfold this part. so that the holes match up again, and then staple. Yes, yes. Good. Now I'm going to start labeling my little tabs right here. Okay? This is vertex at the origin. And I can always open it and check and make sure. Vertex at the origin. This is a vertical axis of symmetry or vertical parabola. Okay? Vertex at the origin, vertical parabola. This one's still vertex at the origin, but it's a horizontal axis of symmetry, so it's a horizontal parabola. So vertex at the origin, horizontal parabola. Even if you haven't stapled yet, you can still write these if you're waiting on a stapler. Okay? This one has a vertex at HK. And is a vertical parabola. Which table groups still need a stapler? Okay. This is a vertex at HK. And is a horizontal parabola. So I'll scoot it back so you can see it from the very top. Now, if I gave you this and said, okay, learn it, that's really overwhelming, isn't it? Isn't this a lot of information on one page? But if I said, let's look at this part, that's better, right? That's much better than to try to think about the whole thing at once. So let's look at this very first tab. This very first tab is the vertex at the origin of vertical parabola. Oh, time out, time out. What do we need to do first?
Oh, yeah.
Flip it over. Okay. Now, first tab. Last week we talked about only functional parabolas, right? You can open the second tab and see we're not just only talking about functional parabolas anymore, are we? Okay. Last week we only talked about functional parabolas and we talked about vertex form and standard form and intercept form, right? Okay. So now there's a whole nother way to write equations of parabolas. Seems like a lot. Well, there's 4. That's not a lot, right? We'll be okay. And there has to be multiple ways because there's multiple things we can know about a parabola. Okay? So if we're looking at this particular way, standard equation of a parabola with a vertex at the origin, vertical axis of symmetry x equals 0. Right? In order to understand what this is talking about, the main thing you have to understand is what is P. Okay? So what I want to tell you first of all is this is an axis right here. This is the x-axis. This is the y-axis. Are you okay with that?
Yes.
This is the parabola. This right here is called the line of directrix, or just the directrix, but it is a line. Okay? And then this point right here is called the focus. What I need you to understand about the focus is always inside of the parabola. That means the directrix is always outside the parabola. Are you okay if I use those two words to describe things? Okay? A parabola is created because any point that I choose on the parabola, like if I choose that point right there, any point I choose on the parabola, the distance from that point to the focus is always the same distance as that point to the directrix. That and that are the same. If I choose that point, that and that are the same distance. If I choose this point, that distance and that distance are the same. Keeping in mind that every time I come down to the directrix, it's always at a right angle. Does that make sense? That's how a parabola is created. What I need you to understand is that the distance from the vertex to the focus is P. The distance from the vertex to the directrix is P. Now P is going to be greater than 0 here and less than 0 here, because even though I'm saying it's a distance, we also have a direction to go with that distance, right? This is going up, so P would be greater than 0. It's a positive number. It's going down here, so P is going to be less than 0. It's going to be a negative number. I'm not telling you that the distance is negative. I'm telling you the direction is negative. Do you see the difference? Okay? So if I tell you the focus or the directrix, do you think you could tell me the equation? Probably. Hopefully. If I told you the equation, could you tell me the focus and the directrix? Yes, because all you would have to find is P, right? Now here's the best news about the whole rest of this foldable. I don't have to explain the whole rest of the foldable because it's all the same. It's just where's the vertex and which direction are we opening. This is a horizontal axis of symmetry, so we're either opening right or left. If it opens right, our p-value is going to be greater than 0. It's going to be positive. If it opens left, our p-value would be less than 0 or negative. Now this one looks way messier, but it's only because the vertex is not at the origin anymore. I could actually use this one the whole time, just with h and k being 0 and 0. That would be 0, and that would be 0. Isn't that exactly the same equation then that we talked about on the first? 1 over 4px squared? Yes? Okay. And then this one would be the horizontal axis of symmetry when a vertex is at the origin. Okay? Now, back up at the first two real quick. We've dealt with y equals y equals y equals y equals forever. Right? Ever since we started graphing, it's always been y equals, and things always opened up or down, right? Those are functional parabolas, so it's y equals opening functional parabolas, okay? Does it make sense that it would be x equals if it's opening left or right? Does that make sense to you? Okay? So what I need to be able to do now is I need to be able to give you some examples, and you need to know how to use this foldable so that you can get correct answers on your homework and quizzes and tests. Does that make sense? Okay, so first thing I want to do is I want to give you some notes. So if you have notebook paper, I need you to go and get that out so we can write some of this stuff down. We'll be referring to this foldable. I'm just moving off to the side so that I can give you some notes. Is that okay? Okay. So if I tell you the focus is at 0, 3, and the directrix is at y equals negative 3, what I need from you is the equation. Okay? But before you can tell me the equation, I want to just sketch a quick graph of this. 0, 3, that's the focus. So the directrix would be here. Knowing where the focus is and the directrix is, can you tell me which way it opens? And how do you know it opens up? What's it doing to the focus? It's eating it. That's like food. I know F doesn't stand for food, it stands for focus, but it could stand for food, and the parabola could be eating the food, right? If it was a monster with teeth, an eyeball, and it's angry. Okay. We're just pretending. You understand what I'm doing, yes? Okay, good. We're just being silly a little bit. All right? So I know it opens up. Well, if it opens up, oh, I just went ahead and put it right at the origin. Could you have figured that out yourself? How? Where is the origin in relation to the focus and the directrix? Right in the middle, isn't it? Okay? It's right in the middle. Because remember I said any point that you choose on a parabola has the same distance to the focus as it does to the directrix. And if I chose the vertex, wouldn't that be the same here and the same here? So if I just told you this, could you have known that the vertex was at the origin? Good. Okay? So now I'm going to look here. I need y equals 1 over 4p x squared. So y equals 1 over 4p. And in this problem, what is p? 3. So what's 4 times 3? 12. X squared. Done. Okay so far? So what if I tell you that the focus is at 5, 0, and the directrix is at 0, negative 5? 1, 2, 3, 4, 5. So if there's the focus and there's the directrix, which way does this parabola open? To the right. And the vertex is at the origin y? Because that's halfway between the focus and the directrix, isn't it? Okay? So this time, that's a horizontal parabola, so I'm going to go over here and flip this open. X equals 1 over 4p y squared. X equals 1 over 4p. Well, what's p in this problem? 5. So what's 4 times 5? 20 y squared. Done. Okay so far? Which part are you not okay with? Thank you for saying yes. Someone else shook their head, so I was just worried about that person. Are you okay? Okay. So what if I tell you the vertex is at the origin and the directrix is at y equals 7? I didn't tell you the focus this time. Is that okay? Yes? Okay, so the vertex is right here. The directrix is y equals 7, so it crosses the y-axis at 7. 1, 2, 3, 4, 5, 6, 7. So where is the focus? Well, this is the vertex, right? So where's the focus? If the directrix is up 7, it's down 7, right? There's the focus. So which direction does this parabola open? Down. So that's a vertical parabola with a vertex at the origin. So we're going to use x equals 1 over 4p, sorry, y equals 1 over 4p x squared. Y equals 1 over 4p. And what's p in this problem? Oh, negative 7, right? It opens down. So 4 times negative 7? Negative 28 x squared. Done. Okay? Does it seem easy? But when you saw this, you thought there was no way it's going to be easy. It's going to be real messy, right? That's why we're taking it parts at a time, first of all. Okay? And that's why we're using a foldable and I'm not making you memorize this. What if I tell you the vertex is at 0, 0 and the focus is at 11, 0? So there's the vertex, there's the focus. Do I need to know where the directrix is? No, but where would the directrix be? X equals negative 11, right? Because it would cross the x-axis at negative 11. Okay? So it is it opens to the up? Oh, to the right. Okay, excellent. That means it's a horizontal parabola with the vertex at the origin. So x equals 1 over 4p y squared. So x equals 1 over 4p. 1 over what? 44 y squared. Done. How would I know if a horizontal parabola was a negative? Which way would it have to open? To the left. Okay, I'm all right with that. You okay so far? Okay, what about this one? Can we go the other way? If I give you the equation, can you tell me the focus and directrix, and what does this stand for, you think? Axis of symmetry. Okay. Now, do I need to graph it? I didn't even need to graph any of the last ones, right? But I did because a lot of you are visual. Okay? So what do I need to know about this? This has to be 1 over 4p. So 4 times what equals this? Oh, negative 4. Excellent. And since it's y equals, which direction is it opening? Up or down. And because we just said p was negative 4, we know it's opening down, right? So where's the focus? Down here, right? So where is that focus then? 0, negative 4. If this is the focus, where's the directrix? Up here at 4. Which axis is it crossing? The y-axis at 4. And what is the axis of symmetry here then? So I just want you to be a little bit more general than that. Usually I want you to be more specific, right? But here we can just say y-axis. If I ask for the equation, you could tell me that that was x equals 0, right? Now, I did all of that without even referring to the foldable, but let's just check in with the foldable to make sure. We said p was negative 4, and the focus is at 0p, so 0, negative 4. You still okay with that? The directrix is y equals negative p. P was negative 4, so y equals negative 4. So y equals 4, right? And of course our axis of symmetry is x equals 0, or the y-axis. You okay with that? What about this one? X equals 1 over 24 y squared. Well, if it's x equals, which directions could it possibly be opening? Left or right? Which direction is this one opening? And how do you know it's opening to the right? Yeah, it's a positive number, right? So pretend that's going through the vertex or at the origin. So where's my focus then? Over here, right? Okay, and my axis, my directrix is over here somewhere. Okay, where is that point then? Because this is 4 times 6, right? So where's my focus? 6, 0. Good, because I have to go right, left to right first in a point. So 6, 0. Where's my directrix? Which axis is it crossing? X equals negative 6. And where's my, or what is my axis of symmetry? It would be y equals 0, but that would be the x-axis, right? So let's check our foldable and make sure that we got what we needed to get. Focus would be P0. We decided our P was 6, so 6, 0. That matches up. Our directrix would be x equals negative P, so x equals negative 6. And our axis of symmetry is y equals 0, or the x-axis. You okay so far? Okay, I got 2 more examples for you. Here's the first one. The vertex is at 1, 2, and the focus is 3 units down from that. Uh-oh, is my vertex at the origin anymore? No, that means I'm going to have to be using the bottom two, right? Okay, my vertex is at 1, 2. That's my vertex. And the focus is 3 units down from that. So 1, 2, 3. That's my focus. So which way is this opening? Down. That way, right? Well, if it's opening down, what kind of parabola does that make it? Vertical or horizontal? Vertical. So let's open this tab. Y equals 1 over 4p x minus h squared plus k. Okay, so let's start here. Y equals 1 over 4p. What is p in this problem? Didn't it tell me that right there? It did, right? Or I could count. I could go 1, 2, 3. I would still get 3. So 4p would be what? Yes, absolutely, it would be negative 12 because it's opening down, so I know it's going to be negative, right? X minus h. What's h again? What's h and k again? The vertex, right? So isn't this h and this is k? So x minus h. So x minus 1 squared plus k. So plus 2. Done. Okay with that? What about this last one? The vertex is at 3, negative 7, and the focus is 5 units left. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. That's the vertex. 5 units left of that. 1, 2, 3, 4, 5 is the focus. So which way does it open? To the left. So what kind of parabola is that? Horizontal. So I'm using this one. So x equals, I need to know what the value of p is. What is that in this problem? 5, right? Or I could count 1, 2, 3, 4, 5. Oh, it's negative because it opens left, right? So 1 over 20. 4 times 5. Ooh, this is different, right? Now it's y minus k. Well, that's hk. Y minus k, y minus a negative 7. Y plus 7 squared. And then plus h plus 3. Questions? When I first gave this to you, were you nervous? Are you still nervous? Oh, just a little bit? That's okay. You're allowed to be nervous. It was the very first time you've ever seen this, right? But having this foldable is going to be very useful as long as you will use it, right? Okay? Any questions?